Okay guys, in our last few videos we've looked at how we can use the law of sines to solve triangles. In this video and the next couple of videos we're going to focus primarily on a specific instance of solving using the law of sines, and that particular instance is only with our side angle type of problems. And so one really easy way to remember that you might run into problems with a particular law of sines case is to say that the sine or side angle case backwards really is this right here. And so I apologize for putting this on the web. I don't promote using poor language, but I will say this. I always remember that, I might have to check this one to see if I have a particular case happening. And so this particular case that we're talking about is referred to as the ambiguous case. And so the ambiguous case, let's start with this. What the heck do we mean by this word ambiguous? So you may have heard this word before. A quick Google search would turn up this definition here. We say of language, it could be open to more than one interpretation or having a double meaning. So if I have two friends standing in the room and I say, she's 30 years old. You're like, well, which one? Because there's two girls in the room. You could mean either that one or that one. That statement would be ambiguous, just like in our particular case here. We're going to look at a particular type of triangle that's open to more than one interpretation. So another definition here is unclear or inexact because a choice between alternatives has not clearly been stated. And so in terms of the ambiguous case here, what do we mean by this? Is we say open to more than one interpretation, more than one interpretation. And so what this is going to mean for us is, and I'm going to tell you here, is that we're going to have particular side angle cases in which we might have no solutions, or maybe just one solution, and in particular instances we're actually going to have two solutions. I know, super exciting, I know. So we're going to take a look firstly at this diagram that you see over here, and what I want to do is illustrate this angle side case. I'm going to twist this around on purpose because what I want you to see is this. In an angle side case, it's exactly that. We have some angle that is set in stone. So this is a known angle right here. And this angle is not allowed to change. Now, we don't know this bottom side, but we do know the two subsequent sides here. And so that would be the side adjacent, or one of the sides adjacent to A, and then definitely the side opposite to our capital A. And so in this particular case, one thing that I do want to point out is that we actually don't know this top angle. And so to open up this kind of conversation about how there may be no solutions, let's start with this. I want you to imagine we had a setup like this where it's exactly as I've drawn, and this top angle here being unknown means that we could actually just swivel this side here kind of around wherever I want it to go, and it would still be A in length. And the fact is, if I were to kind of draw some A length circle here around this, kind of like this, you would see that this side A is clearly never going to be long enough to reach this base side right here. And so in this particular case where I say, well, A is known, A has to be this big, B has to be this long, and no matter what angle you put up here, A has to be this long, well, A is just simply not long enough to reach this other side. And so this is a particular illustration that would illustrate maybe the no solution case. But what I want to start with is that we have a measuring stick by which we always can tell how do we know if we're going to have no solutions or one solution or two solutions. And so what we're going to do on this diagram up here is we're going to drop this down here and we're going to refer to this as the height, H. And so I'm going to put H on this side here and we're going to say H is our measuring stick. Okay. And what I mean by measuring stick is this. We are always going to compare the side opposite our given angle. Okay, side opposite the given angle to H, and sometimes to this adjacent side B here. And so the very first thing I want to do is I actually want to go solve for H here. Now, what I want to point out is that we do have this right triangle that you see right here, and we know angle A and we know side length B, so to solve for H we could just do some SOHCAHTOA math. And so we're going to write an expression here that's pretty important when we talk about side angle cases, and that is going to be that the sine of A here would be opposite over hypotenuse, or H over B, and keeping in mind that what I want here is the H value by which I can measure things with, then we would get this statement right here, and I would put a big box around this. We would say B times the sine of A. And so this H equals B times the sine of A. I'm going to rewrite this one more time because I think this is really helpful. When we talk about where is B and where is capital A, we're really looking at a capital A representing the known angle that we started with here, and then B is this side that is adjacent to this angle here. And so what I'm going to write is this: side adjacent given angle, I just don't have a lot of room, guys, sorry, so I'm going to write this times the sine, let me see if I can go to the right here. Oh, I can't. Times the sine of the given angle. We're really gonna want to be looking at this number from time to time to assess the situation. So now in terms of this situation, let's go back to kind of why I want this height in the first place. That height in comparison to our side opposite here is going to allow us to determine whether we have no solutions or two solutions or one solution. So let's look at the no solution case. And in the no solution case, we said, well, kind of what we saw was that this side length A, which is opposite this known angle, is just really not as long as the height here. And so in that particular case, we're going to list a particular truth here. We're going to say A is less than H. And when we illustrate this, we're still going to illustrate it the same way, but I'm going to illustrate it kind of like this right here. And we're going to say capital A, lowercase a is across from it. We'll call this one B here. And what I'm going to do is I'm going to drop down this height here and basically indicate that A is not long enough to clear H. And so in this particular case, if we can't even get A to reach the other side here, then we definitely have no solutions. Now, in another particular case, I want you to imagine something up here on the original image. Let's say A is longer than the height. Now, what I'm going to do is I'm going to say A maybe is this long here, which looks a little bit longer than the height here, but when I compare this side length A to the original side length B, it's kind of shorter than B. So in this particular case, what happens is exactly what I'm going to illustrate right here. We're going to say A is actually bigger than the H, but less than the side length that happens to be adjacent to the given angle. In this particular case, when I sketch this out, what we're going to get is this setup right here, and so I'm going to say that this is capital A. It's known, we have to know A, and then we know that the side length across from it, let me cast down my height here really quickly, our height. I want my side length this time when I sketch it to be longer than H, so we'll call this B here. And we'll call this lowercase a. Sorry, other way around. Lowercase a, this is b. But essentially, a is longer than h but shorter than b. And in this particular case, you could see that we could make this triangle here. I suppose we call this ACB or ABC. But if I were to swivel this top angle over so that I still have a side length that is opposite this capital A here, that is still a in length, you'll notice how if a is longer than h but less than b, we could also make this triangle that you see right here. And so there are two particular triangles that we could make out of this larger one and this inner one. And so in this particular case, we're going to have two solutions. And the way we're going to look at this is we're going to look at how A compares to H and to B. If it's longer than H, but shorter than B, then we're going to say, well, then I heads up, I know I have two solutions. Now in the last particular case, we say just exactly one solution here. And in the exactly one solution case, what I can tell you is up here on the original diagram, imagine we had a side length that was longer than the height there, but also longer than B. And so in that particular case, let's go ahead and sketch it down here. It would look like this. We would have our, missing bottom side that we don't know yet. We would have our capital A here, so this is our angle A that's definitely known. And we'll say that this is B. What I'm going to do is I'll cast down my H here. So it's a side A that's longer than H, but also longer than B. We're going to say A is clearly longer than the side adjacent to the given angle. Well, what you're going to get is something that looks like this. And the thing is, there's only one triangle that could possibly be made here in this particular instance, just because A is so stinking long. So these three instances are only up here to illustrate for you one thing, that it is very possible that we get one solution, no solutions, or infinitely many solutions. And what we're going to be doing is using this expression that you see here a lot of the time. That h, or the height right here, is just the side adjacent to our given angle times the sine of the given angle. And what we're going to be doing is coming back and checking against this chart here. Is A bigger than h or smaller than h? If it's smaller, then we have no solutions. But if it's bigger, is it also smaller than the side length of the the side length adjacent to our given angle? Or is it just longer than our side length adjacent to our given angle? And we can determine two solutions or one solution. So in the next video, let's take a look at how we can solve some ambiguous case triangles. Cheers.